Hello, everyone. I am Adam McNeilly. I am a Google Developer Expert for Android, and this is going to be the Imposter's Guide to Dependency Injection. The goal of this talk is to take one of Android's most complicated topics out there and try to break it down into its core fundamentals, walk through it in baby steps, and hopefully make it something that everyone is confident talking about and making decisions about by the end of this presentation. That's my Twitter handle up there. I will post the slides there. It's actually going to be auto-posted in a few minutes, so you can go ahead and check that out after the talk, and you can find the presentation over on SpeakerDeck. So what makes dependency injection such a hot topic for years in the Android community, and why is it so scary? I mean, it's scary because we start off with two big words right off the bat. Even these words by themselves sound scary. We've got half a dozen libraries out there that are designed to try to solve this problem, from Dagger and Hilt and Coin and Toothpick and others I probably have forgotten the name of, which leads to countless Twitter wars. At least once a month, someone says, use this, and everyone says, no, use that. And then it just creates this endless confusion that none of us know what to do with. And it gives this feeling of imposter syndrome. And if you've never heard of imposter syndrome, it's this idea that you don't really belong despite having a bunch of credentials in something, and you're worried about being called out as a fraud. I did some research on the origins of imposter syndrome before this talk, found this great article in the Harvard Business Review basically saying, it was titled, "Stop Telling Women They Have Imposter Syndrome." And what I thought was really good about it is it talks about how imposter syndrome doesn't implicitly exist. It's kind of created. There's a lot of unconscious biases that women and a lot of people face that make us feel, incompetent, and that we might not be as accomplished as our peers. And that's all crap, right? And I thought it was really important to call that out, especially because I mentioned Twitter wars. There was a huge thing on Twitter just a week or so ago where a famous tech lead at Meta tried to say that women shouldn't be programmers. And I just wanted to take my chance to say that that's all bullshit. Everyone in here is a valid Android engineer, and you belong in this community, and I'm glad you're here. So imposter syndrome aside, let's go ahead and go back to dependency injection and talk about all the fun techie stuff. I think dependency injection is one of those problems that it's easiest to understand if we try to look at code where we pretended we didn't even know these words exist. So let's talk about some code we would write without the concept of dependency injection at all. Imagine we have a profile view model. This is like the state container of our profile screen. And there's a method in here that's called once a profile is loaded, and we want to make a call to Firebase Analytics to say, hey, we viewed the profile. This is helpful for all sorts of product decisions. I want to know how common is this screen. Maybe I want to see what order they viewed this screen from something else. But the key thing here is that we're calling Firebase Analytics log event directly from the onProfile loaded function. And this might look fine, a lot of us when we're learning to program initially, or even if we look at the Firebase documentation, it tells us to write code like this. But you can probably hint, based on what I'm talking about, this is not great. And what are the problems that this can cause? Well, the first one that I like to point out is, what happens if we try to test this code? We could create a profile view model test class, and then have a test function called verify event tracked, where we create the view model, and then we call viewModel.onProfileLoaded, and then we're stuck. I have no way to verify that a call was actually made to Firebase Analytics. And that's something that I care about. That's an important piece of functionality in my app. I should be able to make sure that that works. And in this particular case, although this isn't specific to the idea of dependency injection, this code will actually crash if you run this on a JVM unit test. You'll get some runtime exception saying the main looper is not mocked. And I don't know the gritty details, but this is basically Firebase's way of saying it's trying to access some Android framework information that's not there, because we're just running a JVM unit test. We're not running on an Android device. And what this really means is we have a dependency on Firebase Analytics, so we need to inject it into this code. And a really common way of doing this, my favorite way to talk about dependency injection, is through something called constructor injection. What we do here is we add a constructor parameter for the thing that we're depending on. In this case, Firebase Analytics. We can even use Kotlin's great language features to provide a default value of Firebase Analytics. And then when onProfileLoaded is called, we call that passed-in version of analytics to say we viewed the profile. And some of you might have a thought right now, which I think is really important and was highlighted in a great tweet by Kelly Schuster, saying, why is it called dependency injection and not just passing stuff in? And I think this is accurate. There's a great reply to her tweet where someone said, dependency injection is a $25 word for a 5-cent concept. Because what we've already seen is kind of the core concept of dependency injection. Our class depended on Firebase. We needed to inject it. Those words make sense. That's their English definition. But they are big and scary, so they make it sound worse than it is. And dependency injection does get a little more complicated, which we talk about later. But its core fundamental like that can be talked about in just a few minutes. And let's look at how this updates our tests now, which is really nice. So now we've got the same code we looked at earlier, but a couple differences. We could create a mock analytics, where we call some fake Firebase analytics, and the implementation of this can vary, but the point is it's not really Firebase analytics, it's some fake version of it. And then, because I've created my own fake version of it, I could write my own function here called verify event logged, and that's my way of saying I want to make sure that when that particular method was called, this particular event is tracked. So now we've got that dependency passed in, we can write some more tests. But I would like to go briefly on a tangent, again, not specifically related to dependency injection, but very closely related, and ask the question, should we be mocking Firebase analytics? And there's two reasons I think we shouldn't. The first one, we might change vendors in the future. Our code is also still tightly coupled to the idea of using Firebase analytics. But what happens when our company comes along and says, oh, we're going to partner with Segment, and we want to use Segment or Amplitude or some other service that's out there? And there's also the philosophical question of, is it really like Firebase analytics we're testing, or do we just care that some event was tracked, and we don't really care where it was sent to? So in situations like this, it's really helpful to create our own interface for what this functionality is that we want to capture. So we could create an analytics tracker interface with some function called track event that just takes in the event name. I think there was a presentation earlier where they showed this can get more complicated. Maybe you have event properties. Like maybe I want to know like what was the profile that was viewed or something. But we can simplify it to just say, hey, some event happened and we want to track this. And then by using an interface, we can create our own implementation for this. We can create our own class called Firebase Analytics Tracker that implements this interface. And then in its track event function, we can just call Firebase directly. Now this class itself, you could argue, is difficult to write tests for. But again, maybe we don't need to. I want the testing perspective to be focused on our profile view model and how it interacts with some sort of analytics tracker. But now that we've created our own interface, we can go ahead and tweak our profile code to use this instead. We'll create a profile view model. The parameter here is now analytics tracker, the interface that we defined ourselves, and it has a default implementation of a Firebase analytics tracker. But because it's an interface, I have the ability to create a segment analytics tracker in the future, change this one line, and then my profile view model still works. And that's the core concept of dependency injection, and also why we care. That idea of swappability that I spent like one sentence on is like the key thing. The benefit of passing in dependencies gives us the ability to change them in the future. And that's going to help as our apps scale, as products shift. Another great example, we all know there's a new image loading library every 6 months. If you have like an image loader interface, you can adapt to those new tools pretty quickly. And it's worth pointing out a relevant presentation from Stuart Kent at 360 Andev in 2019 called Framework-Free Dependency Injection, where he basically takes that same concept we just had of using interfaces around our dependencies and passing them into things, and goes into it a little more in depth than the one example I had, but highly recommend that presentation. So the first part of this talk, and I'm sorry if I spoke too fast, but it does go by pretty quick. I don't think there's anything we talked about that you haven't learned about in your initial Android development studies or code you've never seen before. So it begs the question, what does make it more complicated than just passing stuff in? If it was that simple as constructor parameters, we wouldn't have endless libraries and Twitter wars and confusion. There obviously is more to it. And one of those key points that we can start to think about where this gets more complicated is the idea of sharing dependencies. So in the example of analytics tracking, we looked at our one profile view model, but analytics are everywhere. We have a bunch of screens in our app, and maybe we want to track analytics specific to each of those screens. Maybe they're even component-based, or, you know, I don't see this often, but if there's any sort of business logic that's related to analytics, you could track stuff like that. And we could have an analytics tracker interface that we have, and we want to create one that we use in each screen. But what's important is that we want to make sure that we can swap out that tracker and have each screen updated. So if you remember earlier in the presentation, we had the profile view model with a default argument of a Firebase analytics tracker. That's great. We could do that on every screen. But what happens, again, if we decide we want to move off of Firebase? Sure, it's changing one line for my constructor, but do I want to do that for every view model in my application? Of course not. I would like to create one analytics tracker that can be shared everywhere. So we're going to walk through first a manual way of doing this idea. And we can start by creating a dependency container. We could just create a class, call it app dependencies, and we could put a public variable for every dependency that our application is going to use. So our analytics tracker would go in here, again, with whatever analytics tracker we want to use in our app. Here's where we would define an error reporter, data repositories. You don't have to make it one class. You could think about organizing it into smaller classes, but let's imagine we have one container that is all of our dependencies. We can instantiate that inside our application class. Again, these are dependencies to be used throughout our application. So when the Android application is created, we can create that dependency container. And then we just need a way to fetch those dependencies from each of our screens. So here we could have a profile activity, and what we'll do is when the activity is created, we get a reference to our application and pull that dependencies container. We get the analytics tracker out of that dependencies container, and then we pass that analytics tracker into our profile view model. This sort of concept would exist in each of our fragments, but the nice thing is that we go back to this screen, I change this one line, all of my fragments are updated, everyone's happy. So that's the manual approach. And there was a footnote earlier. Again, if you find these slides online, you can learn more about it. We're programmers. We don't always love doing things manually, but I think that's a really great way to understand what's actually happening, why we need dependency injection, what benefits it's going to bring to our application, things like that. And so all these libraries out there, they just help to reduce the boilerplate from that manual approach. So libraries like Hilt or Coin, those are two I'm going to talk about because they're two I'm familiar with, but even any others, they're all going to follow this same approach and follow that exact same recipe. We create a collection of dependencies. You want to configure your application class as the container for those dependencies. And then you need a way to request those dependencies as needed. These 3 bullet points, this is like all you need to know. I know that it gets more complicated. I know that when we look at a dependency injection library, there's going to be some intricacies about how that library is implemented. But if you keep these 3 things in mind, it will be very eye-opening when you go look at some of their code, and all of a sudden you're going to understand it way better than you probably did before this talk. So I'm going to put my money where my mouth is. I hope you're all going to believe me. We're going to walk through how we can follow this recipe using Hilt, and then again using Coin. And I'm going to show you that what you see here is exactly what those libraries are doing, even if the code looks way scarier than the manual approach did. So let's start with Hilt. And I picked this one, again, because I'm a little familiar with it. It's also Google's official recommendation of a dependency injection library if you need one. And I'm going to, again, say that ahead of time, at least me personally, I get intimidated when I see code that has a lot of annotations on it, because annotations create magic. But bear with me, I'll walk you through this line by line and tell you everything you need to know. So here's what a dependency container looks like in Hilt. We have some class. Here we called it analytics module, and it's got a function in here called bind analytics tracker. So 2 things to point out off this first one. Analytics module is arbitrarily named, but a way to say all the dependencies inside this module are analytics related. And that's just the way I've decided to organize it. You could have a data module with all your repositories. You could have a service module with services, or you could have one single app dependency module that has everything. And what's really cool here is this bind analytics tracker function, because this is doing what we saw earlier in the manual approach. If you look at the return type of this function, the return type is the analytics tracker interface. That's the interface we defined ourselves. The parameter here is Firebase Analytics Tracker. And that reads kind of backwards, but this is basically saying anywhere that I request an analytics tracker, give me that implementation. So if I ever want to change this, I just change that function parameter from Firebase Analytics Tracker to something else, and it will just work. And again, Hilt's more complicated if you want to understand exactly what those annotations mean, but so far, we're just following the same recipe as before. Then we need our application class to be the container for all these dependencies. Hilt makes this really easy through annotation processing. I just give it one annotation at Hilt Android app, and then what it's going to do is anywhere that I had in this last slide, at the very top, you see this at module annotation. What Hilt will do in the application class is find all of those annotated with module and basically builds like a dependency graph that it can use later when it needs it. But this, again, happens automatically. We don't even have to think about it at all. And then requesting dependencies is very similar. We define our activity, fragment, whatever we're using, with the at Android entry point annotation. And then the fields we want to use, we just use this at inject parameter. And again, because of the module we saw a few slides back, where we said for this interface, return this implementation, anywhere I use at inject, Hilt is going to know this is the implementation I need to return here. So it is magic. Like we don't like request the dependency container ourselves. It just kind of happens. But hopefully you can see it followed the same recipe as the manual approach. It just reduced a whole lot of boilerplate for us. So let's look at a coin example, which is going to be effectively the same thing. Coin also uses this concept of modules. I create a module. And then in here, I have a single. Basically what this means is singleton to create one single analytics tracker. And Coin, you could also call it like a factory, which basically says create a new tracker every time. A nuanced difference we don't need to worry about here. But in the brackets, the generic type is our interface. And then inside the Lambda, we put the actual implementation. So same idea. We're exposing an interface of an analytics tracker and the implementation that I want. I change that one line, everything works. We're still happy. Oh, I'm just highlighting that. I was a little ahead of myself there. Application class works similarly. When our application's created, I call start coin. Now it's not as fancy as Hilt, where it can do annotation processing. I have to manually say, here are all of the modules I care about. If I forget to leave one out, I'm going to have a problem. But still, we put them all inside the application class here. And then when we want to request dependencies in Coin, we just use the by inject delegate. But again, as long as we've defined the field with the interface, Coin will know what to do. So hope all of that works so far. Again, both of them are very similar in the recipe that they use to manage dependencies. There are going to be some nuanced differences that I don't really talk about here. I can answer some questions at the end if you're interested. But the key point from all that is the dependency injection library you choose matters a lot less than why you need it. And this is the classic senior developer thing to say, right? Like, it depends. But here, it really is like, the core fundamentals of dependency injection are what I hope people could take away from this presentation. Because dependency management enables several benefits for us. The first one, unit test support. And cool, it's not like I can just write unit tests, but unit tests are really important. We want to have confidence in the products we build. We want to be able to make changes and have confidence that we didn't break everything. Like, unit tests are really important. Having a dependency management system that enables us to write better tests and create more confidence is a good thing. We have the ability to change dependencies. So if we switch vendors for a product, if a company goes out of service, if there's just a newer, flashier tool coming along, we have a system set up allowing us to move to those new things, which is going to help us avoid legacy code. It's going to help us stay with the times and keep our apps up to date as possible. We have an ability to share dependencies across screens. So again, instead of chasing down all of the screens that use an analytics tracker, I have that one spot where I can change it, and everything just works. I guess I'm kind of repeating that. We have one central configuration of all dependencies, which doesn't just help with the swappability, but it helps with code organization. Like, again, on big projects where screens are scattered all over the place, I have one or a handful of files that do all of the dependency management I care about, and it becomes a lot easier to see, well, what services are using, what repositories are we using, where's our error reporter, what does that give me? So I hope this explains sort of the core fundamentals of dependency injection. We went from seeing what does it look like without dependency injection at all, and then why we care, and a little bit into how we could do it manually, how some of the libraries out there help us solve this problem. But of course, like I said, this is a very complicated topic. As much as I wish 20 minutes was enough, it does still get a little more complicated than that. But I want to stress at this point in the talk that if you've followed me up to this point, you should have confidence you can solve, I would say, at least 90% of your dependency injection concerns. What you've learned so far will get you very far in having that scalability, swappability, maintainability. I don't know how many times I could say that in your applications. So I really just can't stress that enough. I'm going to talk a little bit more about other things, but the talk really could have ended here for like the imposter's guide part of it. I think if you follow me up to this point, you should be really proud of yourselves. So I want to propose a little more advanced question, is like, when we talk about creating these dependencies, something we might be concerned about behind the scenes is a word called scoping, which might not be the word you think of implicitly. I don't think it's the most obvious word for this, but scoping refers to like the life cycle of a dependency. So in the analytics tracker case, I want one analytics tracker that I use throughout my entire application. And that's easy to understand. Maybe the same is true of like a database connection. But sometimes we have dependencies that we don't want that to be the case. What if I have like a cache layer that is specific to a screen? And so each time a certain screen is created, I want a new cache created. That's different than having it live for the entire length of the activity. Similarly, there's a little bit of memory management. If my dependency module creates an instance of something for a screen and then that screen disappears, I don't want that hanging around in memory if I'm not using it anymore. So again, that's a little more of an advanced question, and how we implement scoping, whether we do it manually or with Hilt or with Coin, is going to be a little bit different each time. So I don't really go into that, but it's a good concept to understand. So again, if you're concerned really about performance of your applications and the memory your applications are using, you should have this in mind to consider with your dependency management solution. So there's two sorts of scopes that I think there are more, but there are two that I think are really common that are worth talking about. And I kind of hinted at it already. One is application scoped. So some dependencies should be maintained as a single instance for our entire application lifecycle. So this is true of the analytics tracker. This is often true of like database connections, or specifically if there's like a database that's used by every screen. Error reporters, which again, you kind of create once and use everywhere. Or far-reaching functionality. If you know it's going to be shared by most, if not all of your screens, you want to look at like an application scope situation. There are other times where you care about component scope, where dependencies are alive only as long as the components using it require it. So for example, if a presenter for a screen has a cache layer, like you maybe only want that cache to be created and managed in memory so long as there's a presenter using it. And again, a lot of the dependency injection libraries handle this for you. I think I kind of call that out on the next page. Yeah, so how we manage scoping is going to be different depending on which library we use, which is why I don't go super in depth. But hopefully you understand the concept of scoping, why you might care in advanced situations. And the key thing is you now have like a little bit of an understanding so that if you go back and you try to implement some dependency management solution, say you're using Hilt, and then now you can kind of Google Hilt scoping, and hopefully you have a little bit more of an understanding of what it's trying to tell you, and it's not as scary as it often is for me. I still freak out at anything annotation-based, but that's my problem. So to end off, I think we talked about a lot conceptually, but I know sometimes people want opinions. What should I use? What is like the dependency management solution that you should use? And I can't give you a specific one. If you ask me at the end, I'll tell you like my favorites. But what's helpful for this is rather than just say like it's up to you, I want to try to highlight some things that you should consider when deciding what's going to be most beneficial for you and your teams. So hopefully the next few slides will have some guiding principles you can go with that are pretty clear-cut. Is this important to you? this would be a solution that works for you. So start first with the manual approach, the very first one we looked at. I think a big pro of this solution is there's no magic. You write all the code yourself. It gives you the ability to use like find usages in the IDE. Like I can right click on a parameter and see where it came from. With like annotation processing, I have no idea, right? And that was one of the things that scared me in the first part is like, it's just magic, it just happens. And until you see that sort of recipe spelled out, it's impossible to understand. Also gives you slightly easier refactoring with IDE tooling. If I sort of refactor an interface or an implementation, I can have confidence that everywhere it's referenced in the IDE, it'll be taken care of. But some of the drawbacks of this, it's a lot of code to write and maintain ourselves. And we're kind of reinventing the wheel. If there are dependency injection libraries that are less code that solve the same problem, we are reinventing the wheel. So again, there's no hard and fast rule. If you are a person who really doesn't like working with code that you don't understand, those sort of magic libraries, and you're fine with writing a little bit of extra code. I also think if your app is small enough to where you don't have massive dependency graphs, it's not that much extra boilerplate. But large, full-scale production apps, it might be. And if you were to use a library, some benefits of this, reduce boilerplate code. That's the quick one we talked about. It's quick to get started. I think this is kind of the same point phrased two different ways, if we're honest. Like, because there's less code to write, I can get started faster. More complex situations like scoping are solved for us. But a drawback of this is like it can feel like magic, and it's harder to trace usage of dependencies. And beyond understanding dependency injection itself, it also means I need to know the tool used. So it's not just that I need to understand scoping, I need to understand how HILT does scoping. And if you choose to go this route, which is not a bad choice, it sounded like I might have wasn't trying to apply that. If you choose to go this route, we also have library considerations to concern yourself with. So some dependency injection libraries can verify and manage dependencies at compile time. This is a big thing that HILT provides, which is really cool. If I build my app, I know that all my dependencies are going to work. I think a drawback of this, though, is as complexity grows, as you add more HILT modules and dependencies, your build time's going to grow. I don't think it's a lot. I don't mean for that to sound scary, but it's just the nature of how the tool works. Versus other libraries, like Coin that I use, it uses something called a service locator pattern, where it fetches dependencies for us at runtime, which means our build time is going to stay consistent, no matter how much our graph gets complicated. But by doing it at runtime, if our dependency graph is broken, like if I say, hey, I want to fetch an analytics tracker, but I never defined an analytics module, my code will compile, but then it will fail the first time I go try to record an analytics event. Coin does provide some sort of testing tools you can use, and obviously we should never forego manual testing, but that is a consideration. Some teams would prefer longer but more confident build times. So again, it's just kind of up to you. I think one thing I would leave y'all with is trust yourself. Whether you choose a manual DI approach or one of the libraries out there, that's up to you and your team. Choose what you're comfortable with and what provides the most benefits based on the size and complexity of your project. You know, you might have a personal favorite, but two projects you work on could be at drastically different scales and might deserve different solutions. Use what you prefer. And I think that can't be overstated. I'm a huge fan of saying, like, use what you're comfortable with. It's very easy for us to get lost in sort of like fundamental principles. A lot of people will tell me, well, HILT provides compile time safety checks. That's great. It means it's much harder for me to abuse, then I should use it. And I think that's fine, but if you're a person like me who gets a lot of anxiety around annotations and magic code, I don't think that's necessarily true. I think you should use what you're comfortable with. And some of you might disagree with me. Some of you might view that as a benefit. So I don't want you to take me at my word. I want you to use these to figure out what's going to work for you. And again, before you go down that rabbit hole of which of these tools really matters, just don't forget the fundamentals. The fundamental concepts of dependency injection provide better support for testing, which increases our confidence in our products. They also provide flexibility, enable us to make broad changes to our product quickly. And having a dependency management system is a huge step in ensuring lasting success of our applications that we know can withstand the test of time. And I think I landed with perfect 10 minutes for Q&A, if anyone has any questions.